Hello and welcome to Electron Configuration and Orbital Distribution. So electron configuration is a way in which electrons are distributed into different orbitals, which is represented by the level, orbital, and number of electrons in the orbital. The electron configuration is represented by a number, a letter, and a superscript. The number corresponds to the principal quantum number n. The letter can be any of the different sublevels S, P, D, F. The superscript represents the number of electrons occupying an assigned orbital. Example: the atomic number of carbon is 6, therefore it has 6 electrons. The electron configuration of carbon is represented by the picture below. The arrangement of the elements in the periodic table is related to their electron configuration. It can be used to get the following information: group number. Look at the number of electrons in the last filled orbitals. Period or series number. Look at the highest energy level included in the configuration. It is the highest, n. Electrons enter and fill up the different orbitals according to the following principles and rules: Aufbau principle, Pauli's exclusion principle, Hund's rule of multiplicity, and Madelung's rule. Orbital distribution. Electron distribution can also be shown using an orbital diagram. It uses boxes or circles to symbolize the different orbitals in an energy level. Boxes contain a maximum of 2 arrows, upward and downward. Arrows symbolizes the electrons in each orbital. The direction of the arrow represents the spin quantum number. Electrons are first distributed to the orbital with the lowest energy in accordance with the Aufbau principle, which proposes that the buildup of electrons in an atom is due to progressive increase of quantum numbers. This can be represented using the electron configuration mnemonics device. The principal and angular momentum quantum numbers are used to compare the relative energy of the orbitals. This can be explained using Madelung's rule formula n plus L, which is represented by the table below. The principal quantum number provides a way to determine the number of orbitals and maximum number of electrons that can fit in an energy level. Pauli's exclusion principle states that each orbital can accommodate a maximum of 2 electrons. This explains that the s orbital is represented by 1 box. The p, d, and f orbitals are represented by 3, 5, and 7 boxes respectively. The direction of the arrows represented the spin quantum number following Hund's rule of multiplicity that states electrons will enter the orbitals one at a time. The picture represents the Hund's rule of multiplicity. Here is an example of an orbital diagram of oxygen. Notice that for 2p4, the first orbital is paired. Based on Hund's rule, if each orbital is already half filled, pairing of orbitals will occur. The orbital distribution is useful in determining the presence of unpaired electrons. For paired electrons, they are diamagnetic, while unpaired electrons are paramagnetic.
Created using Powtoon.